Okay. No, we don't have to have homework. There's no homework. All right, wait. We're not saying anything yet. We're graphing the ln of x, which is the log base e of x. Now, when you go to your calculator, set your window so it'll look something like this. You know, when you go to your window and you go to y equals, you know, you're going to put in the ln of x. But as far as your window goes, just maybe, well, I don't know. I'm trying to reach the southern audience, too. The window. Yeah, you want your x's maybe -1 to 10. The y's maybe -5 to 5. Something like that. All right? That's a nice little. It started here. It started here. Okay. Look yonder, out the window. All right, now, one other thing that I need you guys to do for this little discovery do now is to go to mode. And if it says float right now, change it to 3. I want it to round your answers to 3 places after the decimal. So if yours says float, just change it to 3. All right. And then the other thing I want you to do, go back to your graph. Once you have it, I want you to find the derivative using the calculator, believe it or not, at different x values. And just remember to do that, you go to your calc menu. So it's second calc, option 6. And let's say I want to know what the derivative is when x is 6. I would just type in 6, enter, and it'll tell you what the derivative is. Okay, so you're going to find the derivative. We're over here. It's this one. So you're going to sketch your graph. You're going to see if you can figure out the domain. You're going to find the derivative at all these different x values. Okay, and see if you can see a pattern. Because we're trying to figure out what the derivative of ln of x is. So we're going to look at the derivative of the ln of x at 1 and a 2 and a 3. See if you see anything in there. And I'm going to check homework. Oh, look what showed up on the board. It's a graph of the ln of x. That's nice. Somebody put that up there? Yeah, it was paused. So you graph the ln of x. That was great. And yeah, hopefully magically it appeared on your paper as well, and at home. And so we're finding out the values of the slopes. Actually, I got ahead of myself, didn't I? Because we didn't talk about the domain. All right, what is the domain of the natural log function? 0 to infinity. Should I include the 0 or not? No, you can't take the ln of 0. So, trying to work here in order. You want to know that you can only take the log of positive values. So you can only take, you know, not only the ln, but log of any base of positive values. Don't include that 0. Don't do it. Okay, so we use the calculator. We use the graph with the second trace, that's the calc menu, option 6, to find the derivatives. So the derivative at 1, you told me was 1. How about at 2? 1/2. Now you get 0.5. Did you get 0.5? You took the ln of 2. I want the derivative. What do you think this is? Well, if you get 0.69, okay, let's look at this one together. What's happening? All right, people, stay with us here. All right, if you want to know that, here's the ln of x. I want to know the derivative of this function at 2. So I press second trace, option 6, and then I just press 2, enter. And it tells me the derivative there is 0.5. Yeah, you want to know the derivative. You don't want to just know the y value, because the ln of 2 is going to be that value. I don't want to know the y coordinate here. I want to know the slope at 2, not the y coordinate. Every time. I don't know what you're talking about. I'll have to say. All right. What about the derivative of the ln of x at 3? All right, so maybe you just, that one time you got a little crazy. Try a few more. What's the derivative at 4? What? How about at 1/2? 2. How about at 1/4? Wow, so we know the slopes of the tangent lines, and we can come up with a pattern. Now, someone raise their hand. If you know f prime of all these values, what would f prime of x be? What would the derivative be? Jan, I know. 1 over x. Bam, did you see it? How many people saw that pattern? A few? 1 over x. Oh, no. Yeah, no, that's good. It has to be different. Yeah, the derivative of the ln of x is 1 over x. So if I have the natural log in front of me here, y equals the ln of x, that's a little steep. And let's say this is x equals 100. What's the slope of the tangent line right there? Oops, that was a little much. 1 over 100. Oh, yeah, that wasn't good. How about the slope at when x is 1/100th? 100. Woo, that's pretty steep over here. Because when you found the slopes, like slope at 4, you didn't wind up with 1 over the ln of 4. You just found that when you found the derivative at 4, you got 1 over 4. Yes. Yeah, the function is ln of x. The derivative is 1 over x. Oh, wait. I thought I got rid of that. Never mind. Okay, so now we know the derivative of the ln of x is just 1 over x. Okay. That was exciting. But do you think I'm going to be happy just asking you to differentiate the ln of x? I'm going to want to put some other function in there, right? You know it. So let's figure out what the rule would be to differentiate the ln of u, where u is some other function. Maybe it's an x squared. Maybe it's sine x. So if you want to take the derivative of the ln of u, let's think chain rule. What would the first part look like? Yeah, well, what's the derivative of the ln of u going to be? Well, the derivative of ln of x is 1 over x. So what's the derivative of ln of u? It's 1 over u, but u is not x. It's some other function. Right. We have to multiply by the derivative of the inside. We can call that either du dx or u prime. What do you prefer? Oh, well. What are we going to do? All right, so I'm going to write it like this. So either I can write it as multiply by du dx, or we can write it as 1 over u times u prime. The same thing. When you take the derivative of y, you get dy dx. You take the derivative of u, you get du dx or u prime, just like you could say y prime or dy dx. Okay, so if we multiply these together, because we can just put the du dx over 1 or the u prime over 1, we could write this as a single fraction. So the derivative of the ln of u would be u prime over u, or du dx over u. Would you like that better? No? Now u prime looks better, right? So the derivative of the ln of anything is thing prime over thing. Right? When you take, sometimes I like to write it this way instead of on the computer. So when you're taking the derivative of the ln of something, whatever the argument is, whatever you're taking the ln of, that goes down here. And its derivative goes in the numerator. This is exciting. I'm going to try some. I believe it. Okay, the first one we're going to try together. And the second one, maybe not. All right, what is our, so we're not taking the derivative of ln of x. We're taking the derivative of 2x. So what's our u going to be? Okay, so this is like our u. That's our inside function. So when we take the derivative, remember it's u prime over u. I like to do the u part first. What goes in the denominator? 2x, right? Once you got that, just look at it and say, hey, what's your derivative? And whatever it is, put that in the numerator. Hey, yeah. All right, so what does the denominator say when you ask it what's its derivative? 2, so that goes up there. And the 2's cancel. Oh my gosh. So we get 1 over x. Yeah, that happens whenever you take the derivative of the ln of a constant times x. You wind up with not all that, it's just for that case. All right, now what I want you to do with the next one is I want you to try to figure out what the derivative is going to be. Remember, it's u prime over u. Put the u down there first. But before you really are sure, I want you to ask at least one other person what they got. So write down what you think, and then check with people around you. Check out with at least one other people. Up to 20, maximum of 20 people you can check with, but that's...
Hey, Ashley.
Check. I want to hear people checking. You can get up and move around if you want to. Oh, how sweet.
This is exciting day.
Right? It's a handsome looking class.
So the derivative, what's the percentage? Annoying. Nobody uses it. Why would you just stuff?
Mike, you check with anyone? Check with Ryan or check with Ernie over there. Ernie, you got to check with somebody. Yeah, get up and check. If you see somebody who's not checking, just go over to them and check with them. Jamie, you check with anyone yet? Check with someone. Some people haven't checked. It's making me sad, yeah? So you're going ahead? XL and X is a product. You can use product rule for that when you get to it. Oh, you're trying to make it x to the x, the ln of x to the x, like putting that up there? I don't know. Oh, you are far ahead of me. Well, let's deal with this one first. All right, now, a couple people didn't check with other people. That's not good. That's not good. I know. All right, so now, raise your hand if you've checked with other people. Jackie, what about you? 2x over x squared plus 1. Anyone get that for the derivative? Yeehaw! So you just take this, you put it downstairs, and then forget about the rest of the problem. Just say, what's your derivative? And put it up there. You're done. All right? Okay, now the next one we're going to do together, because or else it's going to freak you out. What's the u this time? Okay, that's your u. So when you're getting the derivative, what do you start with? ln of x downstairs. Then what do you ask the guy downstairs? What's your derivative? And what is the derivative of ln of x? Now, I love it. It's right. But couldn't we make it look a little better? It's getting the kids upset. No, it's done. Now, I want to know, does this ln of x go up with the 1 or with the x? If you're going to tell me, you got to give me a reason.
Yes.
What do you think? You're thinking the x? A lot of people say the x.
Yeah.
A lot of people are right then. Yeah, because it's like I heard people saying keep, change. In other words, it's division now, change it to multiplication. And then flip means the reciprocal. That's right. So it's 1 over x ln of x. No, you could make it 1 over ln of x to the x if you put this back up as the exponent. Are you thinking of that log property? Yeah. All right. That was good, kids. This is what I thought you were talking about for some reason. Now, this one you're going to check with other people. I want you checking with other people. So go ahead.
Oh no,
Oh, it's so. It's so. Deal with it.
oh my God, is it the thing? Is it the thing? Is it 1 over the thing? Oh, that's bananas. It's 1 over the, is it 1 over the product?
Yeah. Use the product. So u prime's going to be a product rule.
Wait, so it'll be 1 over whatever the product rule is?
No, it's just going to be product rule over u. You're going to use the product rule to get the derivative of u. That's your u prime. And then it's going to be over you.
I'm a little confused here.
So check with other people. I want you checking, kids.
So the one plus L equals x over x over x.
Denise, check if you got the same thing Ernie got. I want to see what Ernie got. What, you got it wrong? Why? Ernie, is she annoying? She is, right?
Honestly, Sydney's so annoying. Miss Mafia thinks Sydney's annoying.
Yeah, I don't blame you.
We all think she's annoying. We all think it.
Maybe I should have got someone less annoying.
The most annoying questions. They're good questions. They're still annoying. No, I have the question that everybody wants. Ashley, let's check your answers. I feel like this is right, but let's ask the question that everybody wants to know. What do we do with the 3? That's one. Silly goose. Wait, Jillian, come back! You hear that, guys? She's yelling.
Ashley Hawkins is a bully. All right, let's get this started because I want to be able to show you something really cool. Oh, Tim's raising his hand. He's volunteering. Okay, Tim just volunteered, everybody. He's volunteering. He's got his hand up. All right, Tim. All right, tell me what you got for the denominator. Beautiful. Now, what do you have for the numerator? Beautiful. Okay. Anyone else get that answer? That's really good, guys. So you didn't? All right, who said it didn't? It's okay. Because when you multiply x by 1 over x, anytime you multiply by a reciprocal, you get 1. We're doing the product rule. First is x, derivative of the second is 1 over x. So the x times the 1 over x, that's just 1, right? 4 times 1, 4, 3 times 1/3. Okay? So we can all agree that we love taking the derivative of the ln of u. But, sometimes, we got all those other rules that we have to still embrace. And don't just, I don't know. So for the next one, we're not just going to all of a sudden put the ln of x on the bottom because that's what we've been doing, right? Simone? Oh. Okay. That was for Simone. So I forgot that book too. I have to do that more often. All right. So what rule are we going to use for this next one? Chain rule. And what rule are we starting with? Yeah. What is that other rule? Power rule. Okay. So let's write the derivative of the outer function. What should we write here? Okay. It's starting to go. All right. Now, so we took the derivative of the outer function. Now we got to multiply by the derivative of the inside. What was that? Nice. And that's it. Right. It's just the ln of x. Your x is your u, so you don't have to call it that, U prime would just be 1. That's it. Because we were only taking, when we got to the inside function, the ln of x. So that is like u prime over u when we got to the derivative of the inside. Right. We weren't putting some other function into the ln of x. We were plugging ln of x into the power rule. Now in this last one here, it's sine of 2x times the ln of x squared. What rule are we going to start with this time?
Product.
Very nice.
Wait, is it? Oh, you leave the x squared with the ln of x squared. The derivative of ln x squared. That's just going to be 1 over x squared.
Times the derivative of the inside. Yeah. So you will have two chain rules within the product rule. Let's do this one because I want to get to something. All right, so let's start this guy. What do we do first with the product rule? First. That's easy enough. Okay, now this is the new stuff. Derivative of the second. What's the derivative of the ln of x squared?
1. Oh, no. Wowza.
It's not the derivative of ln of x, it's the derivative of the ln of x squared. 1 over x squared times 2x, or we'll just put the u prime up top, right? The derivative of the second, because the derivative is the ln of u. Yeah, for the second. You could just, well, that's all that u prime and u business is just doing the chain rule. Yeah. So you can write it as 1 over x squared times 2x if you like. So far we have first times derivative of the second plus the second, the ln of x squared. Ooh, I'm not going to fit it. Times the derivative of the first. Cosine of 2x times 2. Yeah. So I'm not going to fit it here, which is just annoying. It's cosine of 2x times 2. Yes, new 2 cos 2x. All right. Everybody loves a quiet challenge, right? Where? No, because I wasn't taking the derivative of the, if this was the ln of the sine of whatever, if I was taking everything and putting it into the ln, yeah. Yes. All right, guys. Now I need you to do this next problem quietly. It's not written anywhere. You're just going to look at it. You're finding the derivative of the ln of 5x squared plus 3x minus 2. Don't put your hand up until you've thought about it, until I tell you to. So after you think about it for a minute, you're going to decide on an answer. If you think it's 1, you're going to put up 1 finger, 2, 2 fingers, 3, 3 fingers. Okay? Yeah, you need time to think. You could if you want to. You don't need to, but you don't. I've got thinking music for you. Oh yeah, that wasn't good. That wasn't thinking music. That's all I could come up with for phrase. No, no. Sorry. I know, that's all I got. Press this right. All right. Now, at count of 3, you're going to hold up your fingers. It's either going to be 1, 2, 3, 4, 5. Okay, ready? 1, 2, 3. Hold them up. All right, we got it. We got it, guys. We got it. That was really good. It was 3. It was 3. It's u prime over u, right? Good job. Now, there's just one little extra thing I have to tell you about today. Sometimes you don't want to find the derivative of the ln of x or the ln of, sometimes you want the derivative of log base 3 or log, who remembers how you put that? Remember in like algebra 2 trig, you'd have to graph the log base 4 of x, and you didn't have a log base 4 button on your calculator. You'd switch it, change your base. What is a circle? Yes. Okay. What you would do if you wanted to graph, let's say, log base 3 of x, you would either make it log base 10 or you would use the ln. I'm going to use the ln because that's what we know how to do. You could rewrite that as the ln of x, but you have to divide by the ln of the old base, 3. So if you want to find the derivative of a log of some other base of x, what you're really doing is you're finding the derivative of ln of x over the ln of b. That's the change of base formula. And the natural log of a constant is a constant. So we can pull that out. So when we get the derivative, oh, it's not bad. So the derivative is not just going to be 1 over x, because you have that ln of whatever it is down there. It's going to be 1 over the ln of b times x. You just got that little ln of b down there. So if I have the log base 3 of x and I want its derivative, the derivative is not just going to be 1 over x. Who else is going to be down here? Just the ln of 3. Oh, give me a break. It's just a little number down there. And if we apply the chain rule, you know, like the derivative of ln of u is u prime over u? Well, come on, well, we have to. We're almost there. If you want the derivative of a log of some other base of u, it's still going to be u prime over u. It's still your friend. You got this little number down here in the denominator. Yeah, I don't want to say add, though. I just want you to see where it comes from. All right, let's try this. Oh man, I got like one. All right. So it's do your u prime over u, but just put the ln of the old base down in the denominator. Just got this for me. Someone have it? All right, so what's my u prime? What goes up here? 5. What's the ln of b? What's the ln of 3? And then my u? 5x. I mean, we could cancel the 5s. So we'd have 1 over, I'm going to write it as x ln of 3 instead of ln of 3 times x. It looks nice. Yeah, you could. Yeah. Try one more so you have a little bit of practice under your belt. It's easier. Gina, you got ready? That one you could actually, there's one thing you could simplify the x, right? So you could write it as 2 over x ln of 10, or ln of 10 times x. I'm sorry, but you know, you can. You don't need those parentheses. I don't know why I put them. I can't do like another silent, we don't have time for another little silent challenge. I'll have to do another silent, I like that. Well, actually, yeah, try this one. Well, instead of doing this, the summary, I'll do this today. Oh. Well, that's all I could find.
It's 4. Is it? Now I want to look at it. Oh, it's 4.
So the homework's in the book. I got it open. I have the problems if you need to take a picture. Oh, thank you. It's page, it says it on that sheet, but it's 183. And it says it right in the beginning of the notes.
Okay, bye, Ryan. I'll never see you again.
The green book. Wow, that was neat. Oh, we got to turn this off. Oh, I'm going to have to do the summary so kids at home. Yeah, this was 4. I got to do the summary. Derivative of the ln of u prime over u. Derivative of log base b of u is u prime over the ln of b times u. Similarities, they both have u prime in the numerator and u in the denominator.
What do you mean?
And difference is, it might look like, okay, well, the one has an ln of b and the other one doesn't. And you can remember that, you have to remember that there. But if you remember that the natural log is log base e, and the ln of e is 1, there are no differences. It's just that with the second one, you have to remember, you must remember the ln of b in the denominator of the derivative of log base b of u. If you forget it in the other one, it's no big deal because the ln of e is 1. Alrighty, see ya.